Let's make a game where everything can be rewinded. You see, dev screens and backtracking are just annoying. Let's just rewind the game instead to a point where everything was like you wanted them to be. You were still alive, you still had that little boost to jump, you didn't go the wrong way completely, your wife didn't leave you yet because you spent too much time developing an overly ambitious Metroidvania. About a year ago, we went to an offline game jam. The theme was time loop. At the time, I was like, yeah, this sounds cool, but after the game jam, we realized that this just led to every game not having a save state. Ours included. This little fella came up with the idea to make the whole game rewindable. So the base idea is that you go one way. You do something that is persistent in time, like unlocking a door, then rewind the time, and go another way. Does this pattern look familiar to you? Yeah, you're playing as a robot performing a depth-first search, which nicely ties in with the lore of the game. The rewind mechanic brings a bunch of cool stuff though, like no need for checkpoints when you die. We still have checkpoints. But you must be asking, random developer person on the internet, how do you exactly implement such a system? Well, my child, let me take you on a journey. First, let's talk tools. I'll be using this little handy guy, Godot. Why? It has one very important function we will be using. Second, we can write C++ or GDScript code, so the garbage collector isn't here to ruin our day. Third, I love it. Let's set expectations. Stuff that already exists are replay features and limited time rewinding. What I need is something that can save a point in time in O1. Don't worry if you don't know what that means, it just means it's fast. I also need to restore the game in O1. Also, no memory leaks, and the flexible code that can be used on any game objects. Also, no bugs, please. Oh, and you're a senior developer, and don't hallucinate. Let's take Overwatch, for example. You know, that game. It has a replay feature, and a character which can go back in time. For me, it seems like the replay is sort of delta-based. At a given tick rate, the game records the changes that happened, and that's why it's taking so long to load it, because the game has to simulate the match from the beginning. Or at least from some point where a full serialization has happened. Keep in mind that this is an educated guess and I have no clue what the game does behind the scenes. I mean, it's probably drinking breast milk or something. Look at Tracer's ability. She probably has a linked list or something that keeps track of her orientation, position, and ammo count. This is easy enough to implement, but I will be serializing the whole game, so I need another way. So what did I do? Database stuff is out of the picture. Two reasons. One, I'm afraid the game will desync. For example, if something goes wrong with the player movement calculations, like the floating point imprecisions adding up, that could ruin the whole session. Second, since I can just go anywhere in the gameplay, simulating the whole game from the beginning would be just painfully slow every time. So I will be serializing the state of the whole game. You might say, serialize the whole game, every frame with these RAM prices? And you would be absolutely right. We cannot do it every frame. It would be really wasteful, and the timeline wouldn't accurately represent the duration because of the varying frame rate. So we're going to do it at a fixed rate. Right now, this is 100 milliseconds in our game, but it looks like a flipbook now. The player is jumping all over the place, and this breaks the immersion a little. We can just interpolate between our chosen values, and this masks when the serializations have happened. This is a lot better now. Remember this moment, because it will come back to bite us in the ass later. Well, we need a manager who will tell every object in the game that they need to save their current state. We put a timer and a signal on it. After that, behold, the rewindable class. This will be the heart of our logic. It's a node, so we can freely put it on any other node. Every time the manager class fires the serialize event, we go through our array where we can list the names of variables we want to serialize. This neat thing is called reflection. It allows us to get info about our code structure. Here, we can get the value of a variable with the intuitively named get function. And we can set it with the set function. Makes you think, huh? Okay, we can now set the values for a single point in time. How do we restore them? Let's take the player for example. We want to save the player's velocity, position, animation, and animation frame. First thing that comes to mind is a 2D array, which does work, to be fair. Every time we serialize, we insert a new column. Every time we want to restore the state based on the tick count, we can just index it in O1. If you're looking at just the complexity, this looks optimal for us, and a GDScript implementation would be more than enough. But when you're doing this, your computer is screaming, "Mr. Programmer Guy, please, I beg you, the cache hit rates are in single digit. I don't care, keep working. Ah!" So yeah, when you're indexing stuff, the best case, you're pulling the data from the cache of the CPU. This is fast, really fast. Worst case, you're pulling from your SSD. That's slow. But most of the time you're pulling from your RAM. Because pulling stuff from your memory is expensive, your processor pulls more than just the specific value you've requested. It pulls a bunch of values after that into the cache. That's because you usually iterate over arrays, and if you request this value, there's a high chance you will need this value as well in the near future. And what you don't realize, our GDScript implementation isn't spaced in memory like this. It's spaced like this. That's because we're working with dynamic types. Most of the stuff are just pointers pointing to a random space in memory. When the CPU tries to pull more values than what we requested, it won't be able to accurately predict what is needed. And up until now, I've been ignoring the man in the corner. Yeah, we have no choice. Let's hop on to C++. This gives us low-level control over our memory. Why not C#, you could ask? Yeah, I tried. Godot has a neat C# integration, and I wouldn't need to fuck around with compiling to every single platform in existence. We have one singular Linux wishlist, so I need to compile on Linux as well. But you know, he's here as well. Garbage collector is a pain in the ass, and he doesn't like it when you do irregular memory management stuff. And let me tell you, my guy, what I'm about to do is definitely irregular.
¿Quieres?
So back to C++. For every object, we are going to put every single value it generates in its lifetime into one singular array. We can use strides. It looks like this. We can get a singular value by getting our serialization index, multiplying that with the stride, plus the offset of that value. Pretty cool. Now, when we request a value, it will give us approximately these values, and these ones will for sure be used to restore the full state of the object. One more thing. Godot uses variants. What is a variant? A thing that can store a bunch of stuff, like an int, bool, float, anything. Downside? The size of a single variant is the size of the biggest object we can store in it. And in Godot, that is 20 bytes! You mean if I wanna store if an enemy was angry at a point in time, I need to do that in 20 bytes? That is an efficiency of 0.625%, ignoring the fact that we store a boolean in 1 byte. So yeah, our RAM usage can go from 500 megabytes per run to just 14 megabytes simply by casting the values and type packing them. Let's look at our requirements. We can store an object state in O1. We can kinda serialize an object in O1. When we add the new value to our vector, we need to reallocate it, which is O1. But you see, C++'s std vector is tricky. Documentation says it's amortized O1. That means it usually runs in O1, only sometimes in O1. That's because the array always doubles in size. That's perfectly fine for me. Our third requirement, that there shouldn't be memory leaks, is basically impossible. The more we play, the more data we need to keep in the memory. So what's the solution? Let's put a time limit on the game. Neat little mechanic. Now time is of the essence. We put time doors down, so you need to complete the game as fast as possible. But if you weren't fast enough, just rewind a bit and try again. With this, it's guaranteed that the memory usage won't go above the certain limit. Yeah, that's a band-aid. I don't care. We could do one more improvement, but to be honest, I didn't do it just because I don't see it as necessary, and the game performs a lot above the target. But with the time limit, we could pre-calculate the size required for our arrays, and that would avoid unnecessary reallocations, but would consume a bit more memory, and you know how much they cost right now. Now that that's out of the way, remember when I said that the interpolation would bite us in the ass? Well, here it is. What if the player uses our really cool dashing ability? It gives a player an instant momentum boost. You rewind back, you see the position being interpolated and the velocity is being interpolated as well. Now you press play and you just lost half your momentum. That's because you were in the middle of two serializations and the velocity got halved. What's the solution for this? Well, you remember we only did interpolation because we wanted the rewind to look smoother, but we can cheat a little. When we press play, we can just jump one serialization. No one will notice, I promise. Look, Did you notice? No? Cool. No, you didn't see anything. Shush. Good boy. Now, obviously, there's a bunch of things I skipped over. For example, what do I do with the objects once they are destroyed? They can come back. Godot completely breaks if you set the timescale to 0. You get randomly teleported to the Shadow Realm. This shit absolutely fucking sucks. The artist for it died of hunger because you didn't wishlist the game. Look, there's a lot of love and passion in this game. We know it's overly ambitious, but if you wanna support us, you can hit this little button. And that other button. And maybe this button. It will be entering into early access at the end of April. Probably, I don't know, we delayed it like 10 times at this point. If you're interested in my other obscure rewindable problems, or the art of the game, or our 2000 lines beast player controls, then let us know. I wish there was a feature for this. I will keep making PR stuff for a while, until this little fella finishes drawing the backgrounds.